Hello everyone, my name is Tingyu Cheng. I'm a PhD student from Georgia Institute of Technology. Today I would like to introduce my project Duco, which is a scalable direct circuit writing robot for creating high-fidelity large-scale electronics on vertical everyday surfaces. Before I go into the details of this paper, first I would like to thank the great support and efforts from all my collaborators, especially my supervisors Gregory, Abowd, and HyunJoo. Duco is a scalable hanging system that utilizes the two-stepper motors on two sides to drive the movement. Duco highlights three key aspects. It aims to provide a digital fabrication method with involving minimum human efforts to draw room-scale circuits or even beyond on everyday vertical surfaces like walls or windows. First, why do we aim at making large-scale circuits? While currently advances in fabrication methods for electronics have emphasized packing the most functionalities into the smallest form factor, such optimizations have paved the ways for the fabrication of devices with increasing complexity and have brought up many benefits. However, there are certain scenarios that can be highly beneficial if we can enlarge the electronic size. Wall++ has pioneered in this domain by demonstrating how we can turn our room walls into sensing surfaces to track the daily human activity or even gestures. We have also identified several other domains, for example, energy harvester and the real-world 3D interactive objects can be highly benefited from enlarging the circuit's dimensions. And at the same time, large-scale vertical surfaces are ubiquitous in our daily lives, functioning mainly as space dividers or infrastructure coverage. They exist everywhere and take up substantial spaces, yet are mostly used for structural purposes without any interactivities. With these considerations, we propose Duco. Duco mainly uses a drawing pen equipped with different functional inks to additively draw circuits on vertical everyday surfaces, and also a rotary mechanism to switch between tools. And here is an overview of Duco's different functionalities. The central platform of Duco is composed of different parts or even sensors. For example, the force sensor and the linear actuator are enabling Duco's pen extrusion and retraction. And the IR sensor, IR reflector, the servo motor enables Duco's rotation. In order to allow more people to use it, we have also developed an interface to better help people to operate Duco system. With the help of Duco, we have also developed 5 different applications that highlight different aspects of the system. For example, with Duco, you can draw a large-scale interactive piano on your home wall. Or you can choose to draw an FM energy harvester on a window glass sheet, which benefits from enlarging its surface area to harvest more energy. Here we demonstrate by utilizing the printed energy harvester to power the Bluetooth module with embedded thermometer and accelerometer from the ambient environment. Besides single-layer circuit drawing, Duco is also capable of making multi-layer circuits. Here we present a multi-touch sensing wall by using both the conductive pen and the dielectric pen. Also, the conductive patterns that we draw are able to be connected with other IoT devices. For example, you can turn your wall into an aesthetically pleasing and functional surface to control your coffee machine remotely. On top of drawing different types of circuits on daily surfaces by using the drawing tools loaded with different functional inks, Duco can also subtractively make 2D cutouts to assemble it into 3D interactive objects. However, most of the existing interactive objects are fabricated by machines that are non-scalable and taking up plenty of plane spaces. Here we demonstrate by using Duco to draw the conductive patterns first and then make 2D cutouts to assemble it into a 110 cm tall interactive lamp which can perform different types of lighting modes. With the promising application examples, we also did a series of tests to validate Duco's drawing tool and cutting tool. We have paid attention to several key aspects that can affect the Duco's drawing or cutting performance, including conductivity, dielectric performance, resolution, and the smallest feature size. The majority of everyday vertical surfaces are to some degree patterned or textured. With the help of Duco's simple pressure sensor and the linear actuator, Duco is able to detect the contact pressure change and adjust the pen height accordingly. Before I end my talk, I also would like to mention that we have open sourced Duco with an online repository. We envision in the future that more people can use or even extend Duco and deploy the system in different real-world locations or services for extensive large-scale drawing tasks. I will end my talk here, and I would like to thank all my collaborators again. Please visit our paper for more details. Thank you for your attention.